All right, I've put together a simple circuit here. I've got a 10 volt DC supply battery basically. This is the same circuit we had in lab 2. We've got R1 here, 1k ohm, R2 is 2k ohms, R3 is 3k ohms, R4 is 4k ohms. So we've got a total of 5k ohms of resistance, or 10k ohms of resistance, 1 plus 2 plus 3 plus 4, and a 10 volt DC supply. And what we want to do is we want to look at, I want to talk a little bit about ground in this example. So I've got the circuit set up now. I don't have a ground. There's no ground in this thing, okay? Let's see what happens. Let's run the simulation here. I'm going to call this, I'll just call it 3A. You can call it whatever you want to call it. I'll say create here. And again, we'll go with the defaults, time domain, and general settings. All right, so it looks like it ran. Let's hit the run. Let's run PSpice now. All right, what do we get? We got an error message. Okay, warning, ORNet. It looks like there's a problem. It says check out the session log. So let's click OK here. Let's go down here in the session log and take a look. And you can see right here, the second line from the bottom, your design does not contain a ground, okay? Which means, let's click V here. We're not seeing any voltages. Let's click I. We're not showing any current. So we gotta have a ground, we gotta have a reference with PSpice. That's very important. So I'm gonna go over here, I'm gonna grab a ground. I'm gonna go with the OCAP sim one, the one we've been using all along. I'm gonna stick it right here. Right on the negative terminal of the battery where we're used to seeing it, okay? Now all our voltages will be referenced to 0 volts here at this location. This would be like taking a DC voltmeter and connecting the black lead here and then going in and probing the different nodes here with the red lead. All right, so let's go ahead and run this one now. Let's make the new profile. I'll call this 3B, let's say. Go with the defaults. Run PSpice. Okay, if you take a look at the log at the bottom here, no error messages. The netlist generation is complete. Looks like it ran okay. Let's hit V here. Let's look at just voltages first. So yeah, we got 10 volts here. We're dropping 1 volt across the 1k ohm resistor, and 9 volts. We're dropping 2 more across the 2k ohm resistor. 9 minus 2 is 7. 3 volts across R3. 7 minus 3 is 4. And then 4 volts we're dropping across R4. Okay. And again, our current, this is a series circuit. The current is going to be the same throughout the circuit. It's 1 milliamp. And you can see the direction. It's flowing in the, if you look at the orientation where the current value starts, here, for example, it starts on the left side of R2. That indicates the current here in the circuit is going in the clockwise direction from the positive terminal of the battery to the negative terminal of the battery. And again, we're using conventional current flow, not electron flow. So that makes sense, I think. Let's try moving this ground a little bit here. Let me take these off. I'll move this ground. I'm going to stick it. I'm going to take it out first. I'll delete it. I'll grab another ground. And we're going to go with a ground right here. Okay. So now this, again, this would be like taking our voltmeter and connecting the black lead at this point, and then going in and probing the different locations with the red lead and measuring the voltages. All right. So let's run this one now. Let's go ahead and do the simulation profile. We'll call this 3C. Create, go with the defaults, run PSpice. Looks like, check the log, looks like things ran okay. Let's hit our V's here. All right, so what do we got? We got 0 volts here. Okay, current is still flowing in this direction. in the clockwise direction. But we're going from 0 volts here. We're dropping from 0 to a -1. We're dropping 2 volts across R2. So we're going from a -1 to a -3. Does that make sense? We're dropping voltage across each of these resistors, which means we subtract. So if we've got 0 here, -1 volt is a -1 volt. If we got a -1 volt here, -2 volts is a -3 volts, etc. throughout the circuit. Hopefully that makes sense. Current hasn't changed. Still 1 milliamp, still in the clockwise direction. All right, let's turn these off. Now we're going to take this ground and we're going to, now let me delete it here. Let me grab another one and we're going to stick this one right here and see what happens. All right. So let's go ahead, hit escape. I'm going to go up here. I'm going to run the profile. We'll call this 3D. Create. OK for the defaults. Run PSpice. OK. Looks like it ran OK. Before I turn these things on, let's take a look at what's going on. This is the black lead of our multimeter. OK, this is 0 volts. What do you think is going to happen? Let's take a look. There's our voltages. 0 here. Dropping 2 volts across R2. We're going to get a -2 volts here. 3 volts across R3. -5 volts here. 4 volts across R4 we're dropping, so it's a -9 volts here. This is very interesting, isn't it? You've got a 10 volt supply, but you're only measuring 1 volt at this location here. Why? Because you're referencing this node between R1 and R2 as 0 volts. Current, still the same. Okay, still 1 milliamp, still in the clockwise direction. All right, let's turn these off again. Let's move this thing again. I'm going to highlight it. I'm going to delete it. This time I'm going to move it right here between R2 and R3. So now this is our 0 volt point. I think you're getting the hang of what's going on here. All right, so we're going to run this. I'll call it 3. I think we're on E. I'll go 3E. I'll say create. Defaults. Run PSpice. Let's look at our voltages. Yep, 0 volts here. It's our ground. That's what we should have. Okay. Current is still running in the clockwise direction. Okay, so if I got 0 volts here, I'm dropping 3 volts across R3. I'm just going to turn the current off, just so we can see the voltage. Dropping 3 volts across R3. That's going to be a -3 volts here. We're dropping 4 volts across R4. We're going to have a -7 volts here. We're stepping up 10 volts here. Okay, we're going from a -7 plus 10. -7 plus 10 is +3 volts. So we got a +3 volts here. We're dropping 1 volt across the 1 k ohm resistor R1. So 3 minus 1 is 2 volts. And right back to 0. All right, and we'll move it one more time. And again, I think you probably can figure the results here, but let's grab it and move it one more time. We'll stick our ground right here this time. Our reference, our 0 volt reference, okay? All right, let's run that. What are we on, 3F? You can put whatever name you want in these. I'm gonna say create, okay. Run PSpice. Check the error log at the bottom, or the session log. I'm not seeing any errors. Let's hit V here, see what happens. Okay, so now we got 0 volts here. And this node is also 0 volts, okay? So we're going from 0. If you look at our current is still flowing from the positive terminal of the battery to the negative terminal of the battery. So it's going to be 1 milliamp in this series circuit in a clockwise direction. Turn the current off here so we can see these voltages. So we got 0. We're dropping 4 volts across R4. Okay, we got 1 milliamp times 4 k ohms. That's 4 volts. So 0 minus 4 is a negative 4. We continue around the loop here. We hit the 10 volt battery. So we got a negative 4 plus 10 is a positive 6. So we got 6 volts at this node. 6 volts minus 1 volt. We're dropping 1 volt across the 1 k ohm resistor with 1 milliamp flowing through it. 6 minus 1 is 5. Okay. Then we got 5 minus 2. Okay, 2 k ohm resistor, 1 milliamp. 2k times 1 milli is 2 volts. So 5 minus 2 is 3 volts. And finally, 1 milliamp times 3 k ohms is 3 volts. So we got 3 volts at the node here. We're dropping 3 volts across R3. Brings us right back to 0 volts. All right, so just by moving ground around, you get different measurement values, and it can be a little confusing and deceptive. You may say, okay, no matter what, where I stick my ground, I'm going to show 10 volts here on this node, on the positive side of the battery. But that is not the case, because everything is measured, and in this case with PSpice, calculated based on the location of your ground. All right, so I'll stop here.